So I'm gonna share my screen here and then let's begin. Right here, play. Can you see the screen okay there, Ched? Or do we need to move the TV?
Okay.
Trudy?
I'll move a little.
I think, can you go sit over there? It's more of the better angle. Right now we don't need the computer. All right. So yesterday, what did we review there? What is all this stuff there, Wendy? What did we review yesterday? Correct. Okay, so make sure the important thing to know is the operating system. What does the operating system do? And also the von Neumann architecture. Okay, and logic gates. For sure, there's going to be some logic gates, so review about the logic gates. Okay, so have your notebook. We're going to do a quick summary about, so today's day exam review. Day 4, and we're going to do assembly code and maybe if we have time, networking. Okay. Who could tell me what is assembly code? What is assembly code? Yes, you're correct. So we have different languages, right? Is that writing too small?
It's fine.
I can always zoom in.
It's fine.
Okay. Is that better?
Yes.
So in languages, we have low level, we have mid level, and then we have high level languages. Agree? Low level is binary. Mid is assembly. And the high is like Python. Now, what is some advantages of using low, mid, or high level? This is like a triangle, right? What is some advantages of low level program? Who understands the low level language? Yeah. So we have to have low level language because that's basically machine code. Computers can only understand that. Assembly is really good for hardware. Okay, it's very compact and it's fast. It's super fast because it doesn't need any translation. It does have some translation, but it's minimal because, for example, you have LDD, LED4. It understands this section, the data part, and then this is the instruction part that is the opcode, okay? So assembly has two parts. This is called the opcode. David, opcode is the instructions. And then on the second part of the data, we have the operand. And Python is just like English. And so this is easy for humans. It's easy for humans. Now, the key thing to know about programming languages is if I'm at high, we always need a translator. Okay? We need to have a software. Basically, we need to have a compiler. Or you have an IDE. Okay? Or we have a compiler. There's compile, and then there's a other one. What is the step-by-step one? I forgot there, Wendy. You can compile. That means to do it all at once. To translate the code all at once. It means run code all at once. That's to compile. The other one is what? Do you remember? Let's have a look. Build in a computer CPU architecture assembly language. We have compiler, and then what was the other one? It does it step by step. Let me think here. So translate? No, it's not translate. Let me, I wrote it down. Huh? Interpreted. Okay. Yes. Okay. So there's compile and then interpreted. Whereabouts is my, okay, right here. We're doing examples. So there's a compiler will translate all that into binary. Okay. The code, it goes into binary / hex. Okay, these are the only two codes that computers understand, is binary and hexadecimal. And we need to either compile, that means to run it all at once, or interpreted. And that is step by step. Okay. And then the IDLE is basically in Python where it has different color codes and things like that. It just makes coding easier. Okay. Now, we're going to focus today on this guy right here, on the opcode. Okay. And we have this thing called a two-pass compiler. Is it assembler or compiler? Let me just get into, I'm gonna do dual screen here. So I'm gonna go into hardware here, and we're doing the assembly language right here. So in assembly language, so basically we have the opcode and then we have the operator and right here, let me see here, we use an assembler to convert the code. Okay, and there's a two-pass assembler. Okay, right here, two-pass assembler. So let's just do a brief review about the two-pass assembler. Okay, I'm gonna minimize this. I don't need that, and I don't need this right here. All right. So I'm just gonna minimize this. Okay, I don't need this. What is a two-pass assembler is he will take the commands. Does the computer understand? So let me just put here. Two-pass assembler. What is a two-pass assembler? Is on the first pass, he's going to remove the commands like MOV and LDD. Okay? And then he's going to have this thing making a lookup table. Because MOV is going to be some binary code. Okay? And so when we have a code of this, it's going to make a lookup table with the different instructions. Okay? So a two-pass assembler is two steps. The very first step, look right here. Can you have a look? It takes the opcode right here, and it looks at the opcode table, because each instruction, like IN, is like an input for the keyboard. David, okay, Wendy, you're okay? You're not typing?
No.
Okay. So what it's going to do is it's going to take all the commands and make a lookup table. Okay? This is the first pass. First pass. Okay? First pass, it does, it makes a table, lookup table, and it also does the address calculations. Okay? Second pass, it makes it into the machine code. So the first pass makes a lookup table and also converts converts the digit, the addresses. So for example, in RAM, you have the digit and it has a 1, 2, 3, and then it will know its location. Okay. So this is the digit. Do you remember? We have the address and then we have the data. And so it'll have a table to know where it's going to jump to, and also it'll have a lookup table for the mnemonics there. The second thing it does, it actually makes the code. Okay, it makes the machine code. Because computers do not understand assembly. Agree or disagree? The computer does not know what LDD, indirect addressing, 对不对? And so what we have to do is always have to convert to machine code. And that is either through compiling or interpreting the code. And so the thing that you have to remember is for assembly, we have this thing called two-pass assembler. And it does two things. It converts the mnemonics into a lookup table, and then it also converts to the address. Basically, it determines where it's going to jump and things like that, and then it's going to compile to that. So we're going to actually do some assembly table. Okay, is that understood?
Yes.
What is assembly code? Wendy? What is assembly code? Yeah, what is assembly code? It looks like this, remember? You have the address and then you have these. The very first things are called what? These are called opcode. Opcodes. And I believe, is it 16-bit? I believe it's 16-bit, where you have 8 bits is the instruction set. It'll have some parts here. And then 8 bits, I believe it's 16-bit assembly, but you have different version, okay? One is for data. One is for data or the address, and the other one's for instruction. All right. So we're going to actually be doing these table, and then we'll do a trace table. This is called a trace table. And this is what we're going to do today. We're just going to review a couple of the instructions. Now, the instructions, we have 3 different types of instructions. One is called data transfer. Okay, that's moving data between the different locations, or we also in. In means that you're getting the ASCII code. Okay. Can you write this down there, Wendy? Can you close your laptop? Thank you. Okay. Can you write this in your notebook? The instruction type, you have 4 types. One is data transfer. The other one is math, arithmetic. The third type of assembly language code is logic comparison. And the fourth is the flow. Okay. An example is LDD. What does LDD stand for? Do you remember? Yeah, it's direct addressing. And then ADD, what does ADD do? What is it adding? Usually it's adding the data in the register to the ACC. Do you remember what the ACC is? ACC stands for the accumulator. It's the result. It's the accumulator. What is CMP? This is compare. It's comparing if something is equal to something. And we're looking at if it's equal to the data in the ACC. If this is true, then after compare, usually we can have a jump. Okay? This is 跳. JMP is jump. So if something is equal, we can comparing is only if it's equal. It's not greater or less than. We don't use this for A level. Okay, we don't use something bigger. It's only comparing if something's equal. If this is true, we have a a jump if true and a jump if not true. And then it'll jump to the digit. Okay? Are you guys ready? We're going to trace through some opcode and have a little bit of fun.
Is that content?
Pardon me?
What is that? So is this the content? I think it's here.
What one?
The last one.
Jump.
Okay.
This is jump. J-U-M-P.
Okay.
What is ASCII? ASCII is basically keyboard input. And so we also had this as well. Okay. Do you have these four names for the instructions? You don't need to copy this stuff. You just need data transfer, arithmetic, logic, and control flow. And then maybe put an example. And we also should have our cheat sheet. Remember that cheat sheet? Because they give you the instructions. They give you the instructions on the exam. The mnemonics. David. Okay? Can you guys look in your notebook? Do you have the assembly code cheat sheet that we had? You need that. Okay. We're going to continue on. Now, the addressing modes, we have immediate, direct, indirect, and indexed. Okay? And we made a little, they do give you a table on the exam. Okay? So let me just show you an example of a paper, a practice exam with some assembly. So here's some past papers. Okay? So this is A level. Your final exam is going to be just questions right from the A level exam. So let's just scroll down here. Tell me when you see assembly code there. Do you see any assembly code? I'm scrolling down here. Let me know when you see assembly. Do we have any assembly? Nope, that one didn't. Okay, maybe it's on paper 2. Yokana. I'm looking for assembly code. This didn't have. It must be in paper 2. Oh, that's a trace table. So we have logic gates. I don't see any assembly code. Why? Oh, I found it. Can you see this right here? So on the final exam, they will give you this table. This table tells you the commands of the opcode. Agree or disagree? So LDM is immediate addressing. It means that whatever is here, you just put it right into the ACC. Okay? LDD is direct addressing. So that means that, can we make the little cheat sheet right here? Okay? So if I have LDM, okay, and I have the address, and then I have my data, okay, let's make the little cheat sheet. So we have 1, 2, 3, 4, 5, 6. This is the address, okay, and I have LDM number sign 4. What do I do? Here's my ACC. Wendy? We're going to go through each of these commands so that we understand what he do. Because on the final test, we're going to have this. If I have LDM and 4, what do I do? Tell me how do I do this trace table? No, is it indirect? LDM. It's called immediate addressing. So what do I have to do? Load the number and into ACC. So tell me, what do I have to do? So I have LDM number sign 4. So what do I have to do? Here's my trace table. What do I have to do? Where does the data go? This is direct addressing. So just on your piece of paper, draw that. If it's that, it goes right into the ACC. Done. Okay, does everyone understand direct addressing? Let's do LDD. So the next command, I'm going to change back to green. Okay, so LDD. If I have LDD and I have 6, and then this is 200, and this is 100. Okay, Ched, if I have LDD Lil, what data goes into the ACC now? Let's read. It says direct addressing. Load the contents of the location at the given address to the ACC. Huh? Yeah, that means that 6, you go to the location 6 and you just copy that and you put in here. It's 200. Remember how we do that. Okay, so just have this little table in your notebook so you know what he do. Okay, just copy this table. Okay, Wendy, back to you. LDI. So I'm gonna go LDI. Let me go back to green. Okay, so LDI. I'm gonna say 7. Okay, LDI 7. I'm gonna extend my table here, and this is gonna be 5. Okay, show me where do the arrows go, and what is going to be the answer for the is 100. Tell me how do I show my trace arrows? Yeah, this is indirect addressing where it's an address. You take that memory data location and you go to the new address and you copy the 100 into the ACC. Okay, so now the ACC will be written. Wendy, does the computer understand what is currently into the ACC? If I went 4 and then I delete him with 200 and then I delete him with 100, does he know the contents of the ACC? Does assembly code know the contents of the ACC? No, it's a dumb program. He just does one step at a time. So he can actually delete. If you do the wrong code, this is how you make a virus. Okay? Because in here, this is basically von Neumann's architecture where you have instruction with, you have data in your RAM. This is all in your RAM or a register. Okay? And so you could actually, look right here there, Wendy. You could actually make a mistake to actually put data inside and overwrite instruction. This would be the same as making a bug, right? Because he doesn't know what is, if it's instruction data or a data inside, right? So let's just, oh yeah, store. Let's just have a bug. Can you create a bug there, Wendy? I want you to make a bug to delete one of my codes. I want to use STO, store, and I want you to delete one of my previous stuff, one of these commits. I want you to overwrite one of my instructions. So STO, and I want you to store the contents of the ACC into an address that's an instruction. Can you help me? But 8, we don't have that. These are instructions right here. I want you to overwrite one of these instructions with some data. So STO, what number? So 6 is data. If I overwrite data, it's not going to matter. I want you to overwrite an instruction, an opcode that has some instruction. The only opcode instruction we have is in addresses 1, 2, or 3. So I want you to store some data in an instruction set. What address has some instructions? Does 100 have any instructions? No, it's just data. What location has some instructions? Yes. So store where? Give me an address that has some data instruction. 2. So what this is going to do, when I go to this code there, Wendy, what is STO2 going to do? It's going to put the current thing 100 and it's going to put that right here. Look at this. Now it's going to delete this code here and put 100. This would be the same as a bug because you overwrote your code, right? And he didn't know that it was that, but so if you write your assembly code, it can be more customizable and it can also, it's harder to figure out. You have to trace it through because you could overwrite some, okay? So we talked about storing. Incrementing just means to add 1 to the ACC. I think incrementing we're okay. Add, we can add binary numbers together or normal number. It just adds whatever the ACC is. Let's do compare. Okay, the last one, let's do a quick compare. Is this all okay? Can I put a check? LDM, okay? Chad, you're okay?
Okay.
LDD, indirect, increment, make Wanshi. So I think the trouble is this guy right here. Let's just do a compare because guaranteed I'm going to put one of these things on your exam. Guaranteed we're going to have assembly code because we did a whole 3 days about this, right? And we had to do a trace. So let's just quickly do a cheat sheet about compare. Okay. So I want you to, let's talk about CMP. This means to compare. What does compare mean? Compare the contents of the ACC with the contents in the address. So if it has these kind of square brackets, this kind of brackets, that means it's the data. It means the data. Okay? So I want you to put the address and then we have the opcode, operand. Okay? And I'm going to put something right here. C and P compare. Oh, sorry. This is the address 1, 2, 3, 4. So CMP and I'm going to have 2. Okay? 2 is equal to 10 and my ACC is equal to 10 and then I'm going to have J jump. Jump JPE. JPE to 1. Okay. Okay. Can everyone see this code right here? We're going to go through this and then you're going to tell me what he do. This is E and D. E and D. Okay. So, Chad, at the very beginning, the command is compare to. What does this mean? CMP.
Compare the contents of ACT with the contents of address.
Okay, compare 10. Is it comparing 10 to 2? No. It's saying compares this to this. Is the 10 and 10 the same?
Yes, same.
So what we do is we have this little thing called a flag. Do you know what a flag? We have a comparing flag. We're just going to put that as true. That's important because we have 2 types of jump. One is true and one's false. Okay, Wendy. Now, CPE 1. JPE 1. Following a compare instruction, jump to the address if it's true. Was the address true or false? So it's true. So where do I jump to? So I'm going to jump to 1. And if I keep on doing this, tell me what's going to happen.
Forever.
This is a forever loop. And this is how to make a bug or a virus, because this would break your computer. If you run this program, he will never exit. Agree or disagree? He'll never get to the end command because he's always equal to 10. There's no increment or decrement of that number. He goes, blah, blah, blah. This is a forever loop. And that will freeze your computer. So if you had that assembly code and someone opened it, he would never be able to exit the code. He would have to have some sort of interrupt, right? You'd have to have some sort of interrupt to get out of this assembly code. This is how the virus is created. Okay? Yeah.
Interrupted one thing.
You could unplug your computer and then you wouldn't be in that interrupt anymore, right? You wouldn't be in that code. So assembly code also has an IDE and it does have the interrupt, Command C. You can get out of it, but there are some that don't. So you could have it that it's in a loop and then you couldn't. It would cajole that. It would freeze your computer. The only way to get out of that would be Alt Control Delete, right? And then go into the system and close the program. Okay? So sometimes the program or the IDE doesn't allow you. Is everything clear there? Can we actually do an assembly code now and see if we get the correct answer? Okay? So here we go. We have a trace table and we're gonna do this together. Okay? You guys are gonna show me what is this? These addresses right here, what is this? Chad, are these instructions?
Yes.
Or data? Remember we have this thing called, there's opcode, and then we have operand. Operand is data. Slash instruct, the opcode is the instruction. Is this data or opcode?
Oh, cool.
Does it have any instruction?
This is open.
This is only data. This is only data, okay? They're mail instruction because sometimes we have data, sometimes we have that. In this case, we just have data, no instruction, okay? These are memory locations right here. Look, 80 is 10. So this line is already done. We do not need to do. This is done for you. Sometimes it's not done and then we would have to 12. Okay? Okay, Wendy, we're going to start with you. LDD 80. What is LDD 80? Let's go up. LDD is direct addressing. Load the contents of the location of that. Oh wait, tell me. LDD 81. Tell me, what do I have to do? So tell me the answer.
I can see it.
You can't see the screen? We're right here. Instruction is 200. The instruction is 200. It says LDD 81. Tell me what this is going to do.
I need to eat it.
Correct. What we do is we take 8 and we put it into here. Do I need to put anything else here? No, I don't. And so I'm just going to give it a check. Is that too small for you to read on the TV? I think you can see it, but you can hear, right? And so this one is just that. Okay, Chen. Now we're on 201. INC ACC. What does INC do? Let's go up here. We don't need to memorize it. INC. Add 1 to the contents of the ACC or the index register. But we're just going to do ACC.
801.
Yeah. So what's the Jaguar?
9.
Correct. This is Joe. I think we did this one before. Oh wait, Wendy. 202. You guys have to get E by VIN and then I think we are good. 2. STO 83. STO 83. What is that going to do?
is 83.
Store the contents of the ACC at the given address. So tell me where do I put the data? And then 83, I put what? Yes, we copy this right here. Only one thing per one line. Okay, next one. 203, Chet. You are 203. LDI 82. LDI 82.
Where is the I don't know. Where is
LDI is a address of an address, did it?
yes, 80. I need to find where is 82. I know what's the
All right.
where is well I see what
82是80
82 where is the 80s
Huh?
now?
So we
so write the 10 in ACC.
Okay, let's have a look. We have to do the trace table. LDI 82, we go here is 80. That means we go to that address.
Yeah.
And then this address here has 10.
This is
And this goes into
ACC.
the ACC. Okay, Wendy. 204. 204. Compare 83. What is this going to produce? Compare with 83. Okay, tell me. What is this going to produce?
False.
This is going to give me a little false. So this doesn't have a little flake. I'm just going to write here false. David, continue on there, Wendy. JPE. What is JPE? Let's just double check. Jump E is a jump to this address if it's true. Is it true? So what do I have to do here? Yeah. So 205 we leave blank. It's we don't do. Okay? 不能跳 because it's not correct. Okay? Now we're on 206. Okay? Ched, LDD 83. What is LDD?
Find the address and then
Direct addressing. Okay. LDD 83.
83. 81, 81. Put 81 into ACC.
No, right now.
Oh, it's 9. So
Yes. So this is going to be
9.
9. Okay, Wendy, 207. Add 10. How come you can't see? 为什么你看不见? Too small 吗? This is 9. 9 plus 10 is what? So this will be 19. Okay? 208, Ched. We have jump to 210. What do I have to do?
Directly jump to the 212.
J and P
Jump
jump
to the
to the given address. I think we made a mistake because there is no address 210. 对不对?
the jump to the address 210.
Oh, we do have it right here. Jump to here. This just goes here.
So storing 81 means store the 19 in the 81.
Correct. That's 210. 210 is 找什么?
19.
19. Okay. Does that make sense there, Wendy? Let's double check to see if we got this right. Okay? Let's just double check. So this is question number 8 on this exam here. So question number 8. So let's just zoom down. 7, 8. Does that look the same thing? 像不像? Is this correct? Is this correct? Wendy? Is this correct? 8, 9, 9, 10, 9, 19, 19? Looks the same to me. So you guys are okay with the bitwise stuff there. Just note, let's continue on because we have this thing called shift, okay? Because in here, we also have to be able to do this, okay? In your note, can you just quickly take a thing? If it says LSR number 2, okay? Have a look. Let's say I have 0, 0, 1, 0, 1, okay? This is in the ACC, okay? Wendy, this is yours. And I have a command called LSR number 2. Tell me what is the new data in the ACC? What does LSR mean? It says bits are shifted and places to the right. So tell me what is the new data in the ACC? What happens to these bits right here? They fall off, right? So if I'm shifting to the right 2 places, these ones die, and you're adding to 0. So what's the answer? Wendy? What's the answer? Yeah. 0, 0, 1, 0, 0, 1. Okay? 明白? Okay, Ched. If I have this data is now in the ACC, and I have LSL number sign 1. What is the new data in the ACC? What does LSL mean? Am I shifting 右拐还是左拐? Am I going to the right or left? What does this mean?
Shift.
Chen?
Left.
It's left. I want you to shift these bits 左拐一步. What is the jiggle? What is the answer? Shift left. I need to add the zeros. So what do I get? What is the jiggle? All these bits 左拐一步 jiggle 是多少?
0, 1, 0.
0, 1, 0, 0, 1, 0 is correct. Okay? So you guys can shift. They can also have the and or not. Wendy, I want you to close your laptop. Thank you. Okay? We're almost there. Now, the last part, if we can do this, I think we should be good. Okay? I want you to answer this right here. Wendy, can you read the question and then answer this question?
Used to stick into what the input register. All other bits was remain it was
Unchanged. So what does least significant bit mean? 对. So we have bag of bits. The one bit over here is called least significant bit. At the 最左边 is the most significant bit. So we want to enable the last bit. It's write a bit to ensure to make that this is always 1. How do I ensure that this bit is always 1? What logic gate am I going to use? I'm going to OR it with what? So whatever this data is, I don't care what this data is. I always want to make sure. Okay, I'm going to OR it with what? 1. What happened if this was 0? I want it to become 1. So what do I need to OR it with? Yeah, what number? 1 or 0? Let's have a look. 1 or 0 is equal to what? Is equal to 1. That works, right? But this is my data part. Let's say my data was 0. What is 0 or 0, Chet?
0, 0.
It's 0. So that did not work, Wendy. We cannot OR it with 0. So we need to change this. Yes, let's have a try. If we OR it with 1, let's see if the data was 1. 1 or 1 is equal to 1. Agree? 1 or 0 or 1 is equal to 1. So the answer is you need to OR it with 1. No matter what this is, if it's a 1 or 0, he will always become 1. So the answer is OR with 1. Okay? This is the answer. Do you remember doing that on your mock exam? This was on the mock exam. Nizidama? Okay. Chen. The ACC contains this. XOR with FE. What is FE? This is hex. F bien Ardinger. What is F in bagabits? Sigabits. And then nigga Wendy. E. Tell me E in binary. Chad, you tell me F in binary.
1110.
Chad, what is F in 15 into Ardinger? Do the table 1, 2, 4, 8. 15 we have 8 加4是12，对不对？ Okay, 继续。I want to add up to 15. 12加2是多少？
14
Okay,
14
okay. 加1吗？ So F is 1, 1, 1, 1. Agree or disagree? So FE is 1, 1, 1, 1. And E is 1, 1, 1,
0
0. Right? But write the results after we take this bad guy and we XOR it. XOR. What is XOR? We have to draw this. Wendy, what is so we have A, B, and Q. What is the XOR logic?
0, 1,
0, 1, 1, 0, right? So we have to do this math on this. So this is going to be 1, 1, 1, 1, 1, 1, 1, 0. Okay. Wendy, can you XOR these? 1, 0 is what? XOR. 1, 0 is what? Ched?
0
0, 1.
is a child
This is XOR.
of 1
This is equal to 1. 1, 1 is 0.
1
1,
0
0,
1
1,
0
0, 1. This is the answer. Okay, that's it. I think we're okay. So this is all assembly and then left 5. This means shift. Okay, let's do this last one. Okay, Ched. This data, LSR, is this shift left? 左拐还是右拐?
right
That's right. How many step?
5
So I need to just5个0. What is going to happen to these guys? 1, 2, 3, 4, 5. What's going to happen?
delete
Delete. So what is the 结果?
0 0 0 0 0 0 0 1 1
Yeah. We start right here. And then the rest is 0. This is the answer for that. Cool.
yes
All right. That's it. Your schoolwork. Can you guys, so we did assembly. Tomorrow we'll do networking. Can you guys pull out your final exam review? Did you go up to question 29 there, Wendy? Okay. Yesterday's homework. I'm going to have a look. This was yesterday. Today. Today we're talking about this. All right. We have this.
This figure has
So you put in your notebook. I want you to do also some of the stuff here. I want you to work into this. Okay. Can you go right down to,
29.
okay, this is today's schoolwork.
29 what?
Go 29 to 40. Okay? 29 to 40 is today. And I will give you, I think we need to practice one assembly code. So let me just steal one for you to have a try. I'm going to go to a past exam. I have all my exams here. I'm going to copy an assembly code for you to do. If you get it 100%, right, it means you're perfect. Oh, here we go. This is a new one. We haven't done this. Okay. So I'm going to copy these two sheets right here. And can you guys now go on your computer? And under day 4, I'm going to put some practice question for you to do. Here is assembly practice. Okay, for sure there is some assembly code practice. So can you see that I pasted this right here and then you can just use the pen to write? I'm going to make this a subpage. Okay, so go on to the computer, go into content library under mock exams. Go down to day 4. Okay, that's today's day 4 review. Click on assembly code and I want you to have a try. This is to fill in this trace code. Okay, this is the command here. We have LD jump. It's pretty basic stuff there. And do this part right here. Yeah, and this right here. Cool. That's it. Okay, so this is your schoolwork plus questions 19 to 40. Divided. Okay, do this one first. So can you can use the computer or what have you. I'm gonna stop recording.